Okay, so we're here on page 3 of your packet, notes 2-2. And so if you'll remember from yesterday's lesson, a line segment is just part of a line. And it consists of two endpoints and all the points between them. So today we're dealing with finding distance in between things. So to measure the length of something, you can use the number line to find the distance, or you can use distance formula, which we'll get to. So the technical formula of that are just A minus B, and then we take the absolute value. So if you've forgotten this, two straight lines like this means absolute value. Which is the positive value. So that's what that symbol means in math. It's always a positive number because we can't have negative distance. So if we're trying to find the distance between -2 and 6 on a number line, we can just plug them in. -2 minus 6 equals -8. Absolute value of -8 is just +8. Nice and simple. Answer is 8. We could plug it in the other way if I wanted. I could say this is A and this is B, and do 6 minus -2. And then we see, okay, two negatives in a row make a positive, and so that gives me +8. So it doesn't matter which number is A and which number is B, you'll always get the same answer because of the absolute value. If you like visualizing things better, we could just do our number line and do the different places. And let's make this 0, 1, 2, 3, 4, 5, 6. This is -1, -2. And I could just count and go 1, 2, 3, 4, 5, 6, 7, 8. So some people really like the visual, and you're welcome to always draw it out and figure it out. Some people like plugging into the formula. All right, here they have it shown for us. So we're going to say, okay, can I just count? So if I count from P to Q, I count 1, 2, 3. But are those whole steps or half steps? So technically, that is 3 halves. And so I'd go 1, 2, 3, it comes out to 1.5. So something like that, it might be a little easier to plug into your formula of -3.5 is where our p-value is. And then minus -2. That becomes a plus, and that gives me -1.5, which then turns into my +1.5. So again, it's completely up to you. Do you like counting? Do you like to plug it into the formula? All right, Q to R. So again, we could count. This time I'm going to count by whole steps. So 1, 2, 3, 4, and then I have this little half here. And so I'd count that out and say it's 4.5. If I chose to plug it into the formula instead, it'd be 2 minus 2.5. which equals -4.5, which becomes positive. Alright, if I want to go all the way from P to R, I could count half steps and divide by 2, or I can count recognizing every half makes a whole. So 1, 2, 3, 4, 5, 6. And so that comes out to whole number 6. Or I could plug it in the -3.5 minus 2.5 and find out that that comes to -6, which again I make positive. So that's the basics of distance on the number line. So go ahead and flip to page 4. So on this page we have distance on the coordinate plane. And so there's two ways we can do this. We can use Pythagorean theorem, or we can use distance formula. So distance formula is this. You'll have this on any quiz or test. So x2 minus x1. So we subtract the values just like in our number line distance formula, but in this case we square it and add it to our y values, and then we take the square root of them. This is very similar to the Pythagorean theorem, which is just a squared plus b squared equals c squared. And so that's the same as distance equals a squared plus b squared. We take the square root. And so we can do this. We can ignore the graph and just plug in our values here. And so what I have to remember when I'm doing this is my ordered pairs are always x, y. So I'm going to label this x1, y1 because I have to have my xy ordered pair, and then x2, y2. And so then I just subtract them. So 2 minus 8, which is my x2 minus my x1 squared, plus negative 10 minus negative 2 squared. And so one thing to watch here is there's always a negative in the formula, minus in the formula, so if it's a negative number I have to double them up. And 2 negatives makes a positive, so I just change this to a plus sign. And so then I do the math, so this is negative 6 squared plus negative 8 squared. And you can use a calculator to help you with that if you want. When I square it, it goes to positive 36 plus 64. I add those together to get 100. All of this is still in my square root symbol, so to find my actual distance, I take the square root of 100 to get distance equals 10. If I chose instead to plot this on the graph, I could plot out my points and do 8, negative 2, and 2, negative 10, and draw myself a triangle. And then I just label my sides, my A, B, and C, because this would be my right angle. And I count 1, 2, 3, 4, 5, 6, 7, 8, 9. I graphed something wrong. Okay, so I think my labels here are incorrect. So let's check. This is 8 and 1, 2. This is 2 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm checking my work here. Sometimes the labels aren't real exact. This is saying negative 10 and it referring to this line here. And I know I was incorrect because I know it has to be 8 like that. So that's 8. This side I count 1, 2, 3, 4, 5, 6. This side is 6. And I plug it into Pythagorean theorem, which is 8 squared plus 6 squared equals c squared. So 100 equals c squared, 10 equals c. So it's up to you. Do you like plugging into distance formula? Do you like counting out, doing Pythagorean theorem? They equal out the same thing. It's just whether you prefer to graph and count or prefer to plug in the numbers. Alright, so go ahead and pause the video, take a minute, and see if you can find the answer to this one. Okay, so hopefully you got something set up like this. So 5 minus negative 4, 2 minus negative 1. When you did all the math, this one came out to a decimal. And if we round this to one decimal place, remember rounding, we look at this number. If it's larger than 5, that number goes up. And so if you need to see the in-between steps, this becomes a plus sign. So that becomes 9 squared. This becomes a plus sign and becomes 3 squared. So we have 81 plus 9 to get 90. And square root of 90, when we type it in our calculator, gives us this decimal. Alright, so flip on over. And we have one last here. And so this is where we get into our segment addition, which is one of the easiest things we do in math. You see it a lot. But if we have the PQ plus QR equals PR from example 2, so if you flip back and look at that, example 2 here, we had this part we measured was 1.5, this part we measured was 4.5. Instead of counting, if we had just added those two, we would have gotten to the same 6. And so this is an actual postulate that you use. If we're doing proofs, you can use this. It's just saying, hey, we can add the two parts to equal whole. So if you'll remember this very important thing that you see a lot in geometry is just part plus part equals whole. This blank up here just tells us PQ plus QR equals PR. So the important thing we have to make sure is we know what our parts are. So if B is between, I'm going to always draw it because sometimes it's not alphabetical. So B is between A and C, AB equals 4, BC equals 5. I could also label here AB's part, BC is part. So my whole equals 9. The next one, we're not still in elementary school. We can't just do straight adding. So this time we have some algebra in there. This is where it's really easy to draw out my ABC. So always draw your number line. And so I have AB is my part plus part is BC. So x plus 6 equals the whole. And so the whole thing is 24. And so again, I'm just going to do part plus part equals whole. I'll often come in and just draw a plus sign here equals my whole, and I have my equation right there. And so I have the whole equation is x plus 6 equals 24. I now combine my like terms to get 2x plus 6 equals 24. Subtract 6, because I need that to cancel out to 0. So now I have 2x equals 18, and I divide by 2 to get x by itself, so x equals 9. Okay, so now I have x equals 9. Is that what they asked me to find? And they asked me to find the part, so AB is just x, so this is just 9, so I can plug the 9 in here. And then here I plug in 9 plus 6, which gives me 15. So this part equals 15. And then I'm going to check. Does 15 plus 9 equal 24? Yes, it does. So it checks. All right, one last one. So this time we have LM if L is between N and M. So this is one of those that's not quite alphabetical. So L is in the middle. It's always important to recognize between N and M. And so NL is part because that's in the middle, so 6x minus 5. LM is another part, 2x plus 3. And then my whole thing is 3x plus 13. And so again, I just add my part plus part equals whole. So I put my plus sign here. It equals this number, which I bring up here. And so I write out my whole equation, 6x minus 5 plus 2x plus 3 equals 3x plus 13. So see if you can solve that equation on your own. If you need my steps, I'm going to first combine my like terms. So I combine my x's, I combine my whole numbers. And so that gives me 8x minus 2 when I combine those. And then I just carry this down, 3x plus 13. And I want all my x's over on one side, so I'm going to minus 3x from both sides. That cancels out to 0, so I have only 13 left on this side. Nothing has changed the negative 2 because I lined that up x's, and so now I just do 5 minus 3 to get 5x. And then I need to move the 2 away from this, so since it's already negative 2, I have to add 2. Because that cancels that out to 0. I now have 5x equals 15. And my last step is divide. So x equals 3. And they asked me to plug it in and find just LM. So LM is this part. And so I'm going to plug my 3 into the place of x. So that gives me 2 times 3 is 6, plus 3 gives me 9. And so my answer is 9. And if I want to, I could plug in the other parts and make sure it all matches up. So 3 here, 3 times 6 is 18. 18 minus 5 equals 13. Here I plug in the 3 to get 9 plus 13 gives me 22, and I check. Does 13 plus 9 equal 22? Yes, it does, so it checks. That's not, you don't have to check every single one, but it's a really smart step, especially if you're on a test or quiz. Alright, so that's the end of the notes for today. Go ahead and work on today's assignment.